Welcome back to the series. Today, Retrieval-Augmented Generation, RAG, the technique that lets a language model answer using your data, with up-to-date facts and far fewer hallucinations. It's the backbone of almost every serious LLM application in production. We'll cover the full architecture, the components, a worked example, the failure modes, and interview questions. Let's dig in. Roadmap. The problem RH solves. A precise definition, the end-to-end architecture, the core components, embeddings, vector databases, and chunking, retrieval, re-ranking, and hybrid search, RAG versus fine-tuning, the edge cases that break RAG in production, and finally, interview questions and answers. Start with three hard limits of a bare LLM. 1. A knowledge cutoff. It knows nothing after its training date. 2. No access to your private or proprietary data, your docs, your database, your policies. 3. Hallucination. When it doesn't know, it often invents a confident, wrong answer. For a real product, all three are deal breakers. RH fixes all three with one idea. Before the model answers, retrieve the most relevant external text and inject it into the prompt as context. The model then generates an answer grounded in that retrieved evidence, not just its frozen training weights. Retrieve, augment, generate. You're giving the model an open book instead of forcing it to answer from memory. Here's the full pipeline. The user's query is converted into an embedding, a numeric vector. That vector is used to search a vector database for the most similar chunks of your documents. The top matches are inserted into the prompt alongside the question. The LLM reads that context and generates a grounded answer, often with citations. Query, retrieve, augment, generate. But that vector database doesn't fill itself. There's an offline indexing step. You take your documents, split them into smaller chunks, run each chunk through an embedding model to get its vector, and store those vectors in the database. Do this once up front and rerun it whenever your documents change. Two components deserve a closer look. First, embeddings. An embedding model maps text to a dense vector, a list of numbers, that captures meaning. The key property: text with similar meaning lands close together in that vector space. How do I get a refund and return policy end up near each other, even with no shared words? That's what makes semantic search possible. Second, the vector database. It stores millions of these vectors and, given a query vector, finds the nearest ones fast, using approximate nearest neighbor search and a similarity measure like cosine similarity. You ask for the top K matches, say the top 5 chunks. Common tools here include FICE, Pinecone, Weaviate, and pgvector. Back to query time. The retrieved chunks are dropped into a prompt template, typically using only the context below, answer the question. That instruction matters. It tells the model to ground its answer in the evidence and not improvise. Then the model generates, and you can ask it to cite which chunk each claim came from. Concrete example. The user asks your support bot, "What's your refund window?" The bare model would guess. With RAG, the system embeds the question, retrieves the chunk of your policy doc that says refunds within 30 days of purchase, injects it, and the model answers, "You can request a refund within 30 days," and cites the policy. Grounded, correct, and traceable. Chunking is quietly one of the most important choices. Chunks too large bring in noise and waste context tokens. Too small, and you sever the context a passage needs to make sense. A common approach is a few hundred tokens per chunk with some overlap, so meaning isn't cut at the boundary. Bad chunking is one of the top reasons RAG underperforms. Two upgrades that matter in production. Hybrid search combines semantic embedding search with classic keyword search, like BM25, so you catch both meaning and exact terms, names, or codes. And re-ranking adds a second stage. A cross-encoder rescores the retrieved candidates for relevance, pushing the best chunks to the top before they reach the model. Retrieve broadly, then re-rank precisely. A question you'll always get: RAG or fine-tuning? RAG injects knowledge at inference, best for facts, fast-changing data, and when you need citations. Fine-tuning bakes behavior into the weights, best for tone, style, and output format. But it doesn't reliably add fresh facts, and it's costly to update. They're not rivals. Mature systems often use both, and the payoff is real. On questions about private or current data, a bare LLM might be right, only a fraction of the time, and hallucinate the rest. Add RAG and accuracy jumps dramatically, while hallucinations fall. because the model is now answering from retrieved evidence rather than guessing. Same model, grounded context. Now the failure modes. First and biggest, RAG is only as good as its retrieval. If the retriever doesn't surface the right chunk, the model has nothing to work with, and you get a wrong or empty answer. Garbage in, garbage out. Most RAG isn't working problems are actually retrieval problems, not model problems. Second, context limits and lost in the middle. You can't stuff unlimited chunks into the prompt, and research shows models attend less to information buried in the middle of a long context. So cap how many chunks you pass, re-rank so the best ones lead, and keep the context tight. More retrieved text is not always better. Third, RAG reduces hallucination but doesn't eliminate it. A model can still ignore the context or blend in its own assumptions. Instruct it to answer only from the provided context and to say, I don't know when the answer isn't there. And watch security. A malicious document can carry a prompt injection, so treat retrieved text as untrusted input. So when should you reach for RAG? Anytime the answer depends on private, large, or frequently changing knowledge. Support docs, internal wikis, product catalogs, the latest data. When not to. Pure reasoning or creative tasks with no external facts or trivial questions, the base model already nails. Match the tool to the job. Interview prep. What is RAG? Retrieving relevant external text and injecting it into the prompt so the model answers from evidence. RAG versus fine-tuning? RAG adds knowledge at inference. Fine-tuning changes behavior in the weights. What's an embedding? A vector capturing meaning, so similar text is nearby. Biggest failure mode? Retrieval. RAG is only as good as what it retrieves. How to cut hallucination? Instruct answer only from context. Add citations and allow I don't know. Recap. RAG grounds an LLM in retrieved, up-to-date private data through indexing, embedding, vector search, and grounded generation. It beats a bare model on factual, proprietary questions, but it lives or dies by retrieval quality, and it's not immune to hallucination or injection. Get retrieval right, and you can build real products. If this helped, subscribe to @Techfluencer Eval. Next episode, AI agents. See you there.